Now we will move to the last part of the lesson about structural relations. Radford says that any given pair of nodes contained in the same P marker as I said is a tree diagram, will be related by one of two different types of relations, dominance and precedence. We'll start with dominance. What is dominance? Dominance is represented graphically in terms of top to bottom order. That is, if a node A dominates a node B, A appears above B in the tree, as you can see. So A is above B, and A should be connected to B by an unbroken set of branches. So as you can see here, there is one branch connecting A to B, and A is above B. So we say that A dominates B. Dominance is a transitive relation in the logical sense of the term, not the grammatical one. In other words, if A dominates B and if B dominates C, then it is necessarily the case that A dominates C. So if A dominates B and B dominates C, then A dominates C. We have two types of dominance. Immediate dominance. A immediately dominates B if A is the mother of B, connected by one solid branch. Now, if you remember, we said whenever we are going to deal with trees, we are going to use the family tree metaphor. So, like when you studied genetics in science, what appears above is the mother, and what is under are daughters. What are under the daughters are the descendants, the granddaughters, etc. So here we have immediate dominance. Why? Because they are connected by just one solid branch. So A here is the mother of B. A immediately dominates B. The second type is exhaustive dominance. Some node A exhaustively dominates two or more nodes B, C, D, etc. Depends on how many nodes you have. If and only if A dominates all and only B, C, D. What does this mean? So here we have node A. And under A we have B, C, and D. Here A dominates exhaustively B, C, and D. For example, we cannot say A exhaustively dominates B and C. Why? Because D is left out of the group. Okay? So we say A dominates B, A dominates C, A dominates D. But if we talk about exhaustive dominance, it should be A exhaustively dominates the three of them, B, C, and D. That's exhaustive. Now, why are we studying this? To determine constituency. A constituent is a set of nodes which are exhaustively dominated by the same node. So here, the NP, the intelligent boy, is a constituent. Why? Because the NP exhaustively dominates the three nodes under it, which are D, A, and N. Now, if I say, is the intelligent a constituent? This is another way. Not only constituency tests are used to determine whether we have a constituent or not, even trees can be used. Now, if I say the intelligent, why is it not a constituent? Because the NP does not exhaustively dominate the intelligent. We said in exhaustive dominance, all the nodes under it should be dominated. So, this is wrong. And it should exhaustively dominate D, A, and N. This is why the intelligent boy is a constituent, but the intelligent is not. So the intelligent on its own is not a constituent because the NP does not exhaustively dominate D and A. Instead, it exhaustively dominates D, A, and N, and hence the intelligent boy is the constituent. So again, a constituent is a set of nodes, these are the three, which are exhaustively dominated by the same node.